Hello students, we will now go for our lecture 5, and in the last session in lecture 4 we had talked about the rise of the age of the industrial revolution, where I had talked about the new materials and new technologies that came up so rapidly in the 19th century and that laid the foundation of materials and technology that we use in modern architecture today. And we had ended that lecture by telling about the architectural predicament, the architectural confusion, because many new types of buildings were now required that were not there before: railway stations, stock exchanges, shopping malls, department stores. There were no real typologies from earlier times which could show them what these buildings should look like. Let us take the example of a railway station. There was no example how to put together a railway station. Everything had to be done from scratch. But the predicament was, though a large number of buildings and larger typologies are required, architects don't know how to build them, and therefore they had to go back to look at historical ideas from history, and now they cannot use them directly, but they can work from those principles. For example, what were the options the architects used? One was the return to Renaissance in the 19th century. Why? Because they realized that there was a certain flexibility to suit the new building types in Renaissance architecture. Though Renaissance itself had been inspired by classical architecture, Renaissance had taken those classical forms and interpreted them in a new way. Let me give you an earlier example of Andrea Palladio's Villa Rotunda. It is a very famous example where he has taken sacred architecture, the Roman Parthenon, and converted that into a villa, domestic architecture. So, Renaissance period had interpretations of classical architecture, principles were visible, more flexibility was there in Renaissance, which could now suit these new buildings, the urban houses, hotels, government offices. The second option was they borrowed from principles of classical architecture. They said classicism is not a set or is not just a collection of aesthetic conventions, order, arrangement, symmetry, but rather it is a scientific method of responding to the programs and structural requirements of modern buildings. Let us see. For example, we can take the classical principle of symmetry and regularity and bend it to our modern day needs. For example, columns in classical architecture, which are in this organized at this center to center distances, can be modified. The gap between them can be increased, and that gap can be bridged with flat arches stiffened through iron instead of using a lintel that was used earlier in Greek architecture. A much further evolution happened in the 20th century with examples like the Villa Savoy by Frank Lloyd Wright. We have also seen this example earlier in other contexts. Here again you see this is an example of classical principles with these pilotis, these round columns spaced apart from each other, and the facade is borrowing heavily from classical symmetry. Then again, it is sensible to revise the proportions of these structural elements due to the new strength that we have in new materials like steel, and because of the changing demands of function. Therefore, if we have these columns, we can make them very slender, like you see here. This also has a capital, a shaft and a base, or for example this slender steel column here, widely spaced apart. And then in modern times, how Mies van der Rohe began to use the eyes sections. This is the Farnsworth house, and he has spaced them wide apart from each other in the Farnsworth house. Now, classical principles have continued to be used in modern buildings. The classical principles of symmetry, geometry, rationalism, purity of form, etc. Many such ideas in different ways have been interpreted and input into our modern buildings. For example, we have the Fagus factory in 1911 by Walter Gropius, or the Stockholm Public Library in 1928, the Villa Savoy by Le Corbusier, or the Crown Hall in IIT Illinois by Mies van der Rohe. These 4 examples you see are examples of classical principles being used in modern times. And in contemporary times, you see, for example, tremendous classical symmetry in the Kudrowski Pavilion in the Milwaukee Art Museum by Santiago Calatrava. You see this symmetrical circular building of the Apple Park in California by Norman Foster, or you see this very strong central axial symmetry in the National Theatre of China in Beijing by Paul Andrew, and you see the Birmingham Central Library, though not having a very strong symmetry, but reflecting or pulling us towards the idea of symmetry in the Birmingham Central Library. We saw then classical principles in different ways appeared earlier in the 20th century in the Glass House 1949, the National Gallery of Art by I.M. Pai, the Hong Kong Cultural Center. And this building, though seemingly not at all classical in symmetry, borrows from classical principles. You can read it up in the Getty Center by Richard Meyer in 1997. Classical principles were also adopted in tall buildings. You see them appearing in the Seagram in 1958 or in the Bank of China Tower in 1990. Definitely very clearly evident in the Petronas Tower in Kuala Lumpur by Cesar Pelli, and it appeared in the Lotte World Tower in South Korea by Con Pedersen Fox in 2016. Now the reason why I am showing you these new buildings of early 20th century, late 20th century, early 21st century is because I want to connect those developments happening in the 19th century with today's architecture. So you as students and as viewers of this presentation can link the changes happening there with the advances they led to in the 20th and 21st century. So of course these buildings look very different from the buildings that, for example, we see here, like the House of Parliament. This is an earlier building of the Gothic period. So from comparing this building, for example, with these buildings, there is a vast difference in the way the buildings look, but hidden inside them are the principles these buildings had used. For example, another thing they had used was Gothic architecture. And from Gothic architecture, this is the Canterbury Cathedral, built in 1070 to 77, about 1,000 years back from us, has then got borrowed in the design of the House of Parliament in London by Charles Barry and Augustus Pugin in 1840. You can clearly see the evidence of Gothic architecture in the House of Parliament. Or therefore, this architectural option, this Gothic revival took place, and its skeletal expression we see in the 19th century all the way into the 20th, 21st centuries. For example, if you see these ribbed forms in a Gothic cathedral, then you find this kind of form in this station by Calatrava, I believe, or in this building, or even in this. So this skeletal expression of exposed tensile members that we see in Gothic architecture has a much wider reflection in the 20th and now in the 21st century. We find so many buildings, particularly if you want to have a specific example, it is the work of Santiago Calatrava, where these tensile steel filigree of members is what you find in his buildings. Now, Gothic revival also permitted irregular plans, like in the House of Parliament, which were more informal and less inhibiting. Now, Gothic in modern architecture as an aesthetic appears in many buildings, in skyscrapers, for example, or in many buildings it started appearing, or in the form of elements of Gothic architecture. We saw this earlier also, that these flying buttresses are seen in modern buildings. So we've seen Renaissance principles, classical principles, Gothic revival. The fourth option, which I would say in a sense had a much wide application, was eclecticism, collection of historical styles. One very interesting building is this one, where you find that this building has an Egyptian pylon, a Greek Parthenon temple, with the Hindu Shikhara on the top. So here I have just put the images together. I wish I was much better in AI to do something with it, but here you have it, the Egyptian pylon mounted by the classical temple, mounted by the Shikhara. Eclecticism. Now, how in the Shikhara here in London? Because the British Empire was extending in all these regions. So we see eclecticism in one famous example of the St. Pancras station in London by William Barlow, 1864 to 68. It has got a style, you can clearly see a part of it is Renaissance, another part of it is Gothic Revival, Gothic architecture, and the building has iron hidden outside and exposed inside. If you remember last time I told you that architects dealt with iron in three ways. First, by hiding it both inside and outside. Second, by exposing it inside, hiding it outside. And the third, finally, we will look at it in Crystal Palace, exposing it both inside and outside. The Crystal Palace was not designed by an architect, but by a gardener called Joseph Paxton. Now, no type available to express and articulate the junction between the head building and the train shed is how Kenneth Frampton defines it. That means at the point of junction between the main building on the outside and when the train shed begins or the vault begins, there is no clear way of harmoniously putting them together that one flows into the other. It was very clear that the building is eclectic, the train shed is a technological marvel, but both are not fusing together organically. That articulation is not clear. Talking about the iron vault itself, it stretched over the tracks and you can see this massive vault in St. Pancras station. And not only it's an iron vault, I told you earlier, it's also having glass fitted inside it so that the daylight can filter in. I get really excited when I look at this because I know that this is going to lead to far greater things all the way into our modern architecture today. This engineering was much more forward looking than the architecture. The architecture was backward looking. The architecture was borrowing from history, but the technology that we see in the iron vault was looking ahead into a later period. So the art itself is not having that rapid progress as technology is having. Now, evolving construction techniques which led to this large span structures, this is a 74-meter clear single span. Now, please understand that this development that you see here was made possible because of bridge construction, because of bridges like the first one in Colebrookdale leading on to larger span bridges gave them the idea that steel could be used for spanning spaces without intermediate column support, and thus these large spans iron vaults came up in stations also. Do you see how one development in technology is leading to another? How exciting architecture is becoming. And here the total length of the vault is 213 meters, about 700 feet, and the only thing, as Kenneth Frampton says, is that there is no clear articulation between the building and the shed. The shed is totally separate from the eclectic building. Now, this comprehensive architectural solution was very much needed as the railway stations, the railway terminuses, the railway termini became the new gateways to our cities. Today the gateways to our cities are airports. That is why there is such a lot of architectural effort made in designing magnificent airports. In those days, that gateway used to be the railway station. Now, the earliest architectural resolution happened in a station in Paris in 1852, where there seems to be a much better articulation of the built form on the outside leading to the vault or the shed on the inside. Much better articulation. Now, if you look at these 19th century stations today, they have not been pulled down. They are being reused, they have been renovated for modern use. You can find that in the Pancras station, you can find that in the Paddington station. Both 19th century stations. We saw this shed earlier. If we go back in this slide, you can see this shed here. This of course is also a modern picture of how the shed is today, and you find this change happening, but Now, what does this show us? The one thing, of course, is the building is still durable. More importantly, the iron shed is still pretty much structurally safe as it was in the 19th century. But stations have undergone a massive change. So, I will correct my statement by saying that today railway stations are also becoming those gateways to cities. They are very symbolically important, and particularly we find that in Europe, with this station in Belgium having a large span, and you can see how technology has evolved. This is also in glass and steel. The span is way larger than in those days, and it is much more magnificent, it is much more geometrically abstract and attractive compared to the simple geometry of the iron vaults in the 19th century. So, if you compare two vaults, for example, this is that St. Pancras 1864 versus this station in China having this vault in 2010. These are what contemporary stations look like. This one, and this one, and this one I am more interested in, because this is the vision of what the New Delhi station is supposed to look like when the new building comes up. Now, another place where a major change happened was in the iron marketplace. Now, the iron marketplace represents major socio-cultural changes. Now, the reason why it is important is because now they could cover markets with these vaults, these framework of iron and glass in terribly cold conditions in Europe. From the harsh climate, the entire shopping experience could be protected, and because of steel, they could still allow daylight to filter in through the glass. So, you can see now not only railway stations, but marketplaces are also changing, and this led to the development of the department store and the shopping arcade. Very major development because of the changing social structure, because of vast urbanization. There was a vast population in cities, and this population was leading to the development of the middle class, because factories, they were working in factories, in railway stations and allied services. These people had money. Factories were producing goods in vast quantities which were much cheaper than the earlier products made in home guilds. These people could afford this, but these vast quantities of materials had to be sold not through one single shop, for example, but an entire department store or shopping arcades. This was another impact of iron and glass, that these shopping arcades or these department stores, for example here, could be covered by these structures or framework in iron and glass, and they had a dramatic appearance of the department store in the mid 19th century. Now, there was a completely new shopping experience which permanently reshaped our shopping habits because of mass produced goods having lower cost, variety, accessible to the new rising middle class which had a disposable income. So, can you see, it is not 2-3 things are working together to change architecture. One is, of course, the technology leading to the covering of these spaces and being able to work and shop in them even in harsh conditions. That is number one. Number two, the social change that is happening, because people have shifted here, middle class is rising, goods are becoming cheaper, they need to shop, they need to buy these goods, so the need of a shopping experience. And there are other changes that are coming in, which I will talk about. Now, these department stores became popular hubs of urban life, having shops and cafeterias and theatres. It was a complete shopping experience, so much akin to, similar to the shopping experience we have in our urban areas today. You go to a shopping mall on a weekend, it's not just to shop, it's also to have a bite, it's also to catch a movie. It's a total experience, and the idea was crystallized in the 19th century. Now, these in-store amenities had restaurants, restrooms and lounges, and there were rich materials used because to attract customers into their environment, with mosaic floors and marble columns and ornamental plaster to create a luxurious setting so that more and more common people would enter in. And we have famous stores coming up at that time which are still very famous across the world today: Macy's in New York, Harrods in London, Printemps in Paris. Now, the concept itself is A department store offers a very wide variety of goods in a single location. They are organized into different distinct departments under that one single roof, so that you could buy different goods from different departments and the shopping experience becomes more easy. There is a rational arrangement making it easy to find your product that you are looking for and an efficient use of space. Now, the shopping mall, somewhat different in the concept of department stores, pretty much follows a similar pattern. Now, the other technical or technological advancements that helped in the shopping or the department store is the improved transportation. People could now move more easily within the cities through public transportation. For example, streetcars or railways. Streetcars within the city, railways connecting from town to town, city to city, steel and glass of course, along with elevators. Elisha Otis came up with the modern elevator in around the mid 19th century. We will talk more about it in Chicago when we talk about the tall office building. The one more thing that happened was gas lighting. Gas lighting helped to make the shopping experience alive at night. Now you could finish your work in the day and come to shop in the night, and thus we have major department stores coming up like Le Bon Marché in Paris, where iron was hidden outside, exposed inside, and it had this huge space in between, in the middle, where iron and glass frame was there and light would filter in. So the form itself is regressive, it is looking backward, with the technology being used as progressive, looking forward. Now, how the Bon Marché itself is transformed from what it was at that time to what Bon Marché is today in the 21st century. And then modern department stores, shopping malls have come up all over the world, starting from Southeast Asia, Singapore, Europe, India, America, etc. China of course. And these modern department stores have atriums. Nearly all of us have experienced this when we go to, for example, a shopping mall where there is a huge atrium which is covered by this framework of glass and steel, and light is filtering in. There are these escalators running or even elevators running through and through and giving you this vast shopping experience. Another building that came up was the iron commercial building. When you produce goods at such a mass level, you need to sell those goods even at a stock exchange, or when you are producing farm produce, there were corn exchanges for them. Another building taking advantage of the iron and glass because of this kind of framework that can come at the top, and in the same building in the corn exchange here in Leeds, light can filter in. These are the modern day exchanges, contemporary exchanges that we find. This is the Midwest Commodity Exchange Center in China. It is a trade center for metal products, and you see how marvelous kind of forms we are coming up today. It's got completely new design details. It's got how we can now use technology to create such kind of access within the buildings, and we are using another new material called structural silicon glazed curtain walling system. Now, like I said, I will continue to go back and forth to completely stitch together this picture of modern architecture. So, I will talk about structural silicon glazed curtain walling system here. Coming up in our modern times, it is glass which is bonded to the building structure using a silicon sealant, and the bond can support the weight of the glass without any additional support. It can withstand wind, rain and temperature changes. Now, this kind of walling system we find in high-end buildings all over the world. Wherever you have buildings in glass or facades in glass, curtain walls in glass, without having any transoms and mullions, then you can understand that is a silicon glazing system, where silicon is the sealant connecting one pane to the other. You will find them in public buildings, commercial buildings, in airports, etc. They are used in high wind and high seismic areas to improve the structural stability of the envelope. Now, how the exchange floor itself has changed. Again, through pictures, this is what it used to be, this is what it has become. This is an older building, I believe this is the corn exchange in a new form, and these are the modern buildings that you find, the exchange buildings. Of course, in this particular one, I believe this is in Canada, you find that they are using postmodern features, the postmodern architecture having columns with base, shaft and capital. We will talk more about it later. These are other examples of contemporary stock exchange. The Berlin Stock Exchange, this is the I'm so sorry, forgive me. This is the Berlin Stock Exchange. This is the outer picture, this is the inner picture, and this is the Dubai International Financial Center. So, how those forms have changed. Now, with these changes in architecture, architects also started reinventing themselves. One of them was Henry Labrousse. Henry Labrousse was not just an architect, he was also an architect gifted with structural understanding. So, we find gifted architects adapting these structural advances in their buildings, and buildings started functioning more homogeneously. So, the iron cultural building is another typology that came up, and this was the Bibliothèque Sainte-Geneviève in Paris, designed by Henry Labrousse. It is a library building 1844 to 51, and in this building you will find that there are these barrel vaults inside which are being supported by iron columns here, and we will look at here they are. These are the iron columns here having base, shaft and capital, and it is very slender. It is not like a stone column, it is a steel column, and in fact it also has fluting. So, there are these iron barrel vaults supported by these iron columns. There are twin barrel vaults supported by this column, and there is light filtering in through these Renaissance windows. Then he moved on to another library building called the Bibliothèque Nationale in Paris, in which he brought in oculus eyepieces from which light was filtered in. He created these domes, and domes were supported over these iron columns, having a base, a shaft and a capital, but very different from the earlier columns and very slender. So, we find Labrousse marrying his structure more homogeneously with the iron frame inside. What Kenneth Frampton had said about railway stations, that kind of articulation between the outer building and the shed is missing, seems to be addressed by architects like Henry Labrousse, where you find that the iron frame seems to be more homogeneous with the rest of the building. But modern libraries, of course, are very different. With Seattle Public Library in 2004, Rem Koolhaas is an amazing example, and we will probably come back to this because of its structural system, which I believe is a die-grid. And we have this library by Meccano in 2013 in Birmingham. We have modern libraries like the Book Mountain and the Library Quarter in the Netherlands, and you can see what an amazing space has been created inside. So, we see what I have done in this entire presentation is I have tried to connect those older buildings, those principles that began to be used there, and how they have started getting reflected in the buildings of today. So, that also indicates those changes were so vital that happened during that time, and they have impacted our buildings today. I will continue to go back and forth like this, and by doing that stitch the entire the picture of modern world architecture. Thank you.